So the next topic is maximum number of possible zeros. Very easy topic, and but yeah, it will be a bit apart from whatever you studied till now. See, we know that degrees can be 0, 1, 2, 3, 4, right? 1, 2, 3, 4 to infinity. So the heading is maximum number of possible zeros. Okay, so it is relating the degree with the maximum possible number of zeros. So if the degree is 1, the maximum number of possible zeros will be 1. If the degree is 2, this will be 2. If the degree is 3, this will be 3. If the degree is 4, this will be 4, so on and so forth. So basically, the maximum number of possible zeros will be equal to the degree. That's the whole relationship. So it's quite simple relationship. There's nothing complicated over here. But there is a technicality. I've used the word maximum number of possible zeros. What does it mean? Well, the zeros need not be equal to this. What does it mean? I made a note here. This is the maximum possible, not a must-have scenario. So I'll show you an example, then you'll understand. So here too again, we are looking at linear equation first, then we have quadratic, and you have cubic, right? So we have different relationship. Okay, so we look at the graph and try to understand what is that what does this statement mean? Okay, all of this, what does it mean? What does the word possible mean? So we'll have a look at that. So let's execute this. Okay, so it's clear that we have two polynomials, polynomial 1 and 2. So we have a line which is horizontal to the x-axis, and we have a green line passing through the x-axis. See, the thing is, this red line is horizontal, meaning it will never pass through the x-axis because these two are parallel. So it will never pass through. If it does not pass through the x-axis, will it have a 0? No, right? For no value of x will this line pass through the x-axis. So basically this red line does not have a 0, while the green line has 1, 0. So basically here what we saw was maximum possible zeros, meaning possible zeros. Matlab you can have zeros up to 1, but need not be 1. So possible zeros are 0 and 1 in this case. Means you can have no 0 if not 1, 0. Right? When it comes to linear equation, you can have either 1, 0 if not no 0 at all. Make sense? Right? So let's understand it a bit more by taking up few more examples. So we'll go with quadratic polynomial now. Right? Let me execute that, and we have the graph. So here, right? Okay, so we have two graphs, and this is your x-axis passing through the 0 of the y-axis. So you can clearly see this graph. If I zoom out, right, you can, if I zoom out and if I rearrange this a bit, right, so we can see that this particular, for the green graph, is passing the x-axis at two different places, while the red one is not passing at all. So in this case, the number of zeros were 0 and 2. But yes, I'll give you one example wherein there is only one value, 1, 0. Okay, so technically they call it as 2, but numerically it's just 1. So yes, again, here the maximum possible 0 is 2, but yes, you can have no zeros at all. Right? Again, remember, zeros are that value, that input value, which makes the output to be 0. So for this graph, red graph, there is no value in real number which can make the graph pass through the x-axis. There's no real number which makes it possible. Okay, you cannot split the middle term, you can't do anything about it, right? So it is fixed. It won't cross through your x-axis, and the number of zeros in that graph is 0. Okay, so again remember, the maximum possible zeros does not mean it should have those many zeros. No, it need not. So let's take one more example. Let me block this, unblock this, and yeah, here if you see carefully, right? Okay, I need to rearrange this. Can you see that? It's just touching the x-axis and going. Right? Both of them are just touching. Actually, this is crossing properly, but yeah, this is touching and going. So let me make them touch and go. So this is 4. Yeah. This is what I was looking for. Oh, this was 6 itself. 2, 3. That's correct. Okay. Now it will be proper. Right? So we have let me rearrange them. So yeah, it's crossing the x-axis, right? It's proper. Now look at the zeros, -3 and -2. They're just touching the x-axis and going, right? So numerically there is said to be only 1 0. But yeah, technically they consider it as 2, 2 and stuff like that. -2, 2 and -3, 3 are the zeros. They write that. But yeah, I mean, numerically there is only 1 0. So yes, the point is a graph can have no 0 or maximum of 2 0 when it comes to quadratic expression. When it comes to cubic, I'm sure you would have guessed it. It can be 0, 1, 2 and 3. And for quintic, I guess if I remember right, it will be 0, 1, 2, 3 and 4. These are the possible zeros. Remember, this heading is possible zeros. Possible number of zeros. Okay, does not mean it should have that. It should have this many all the time. No, it can have any one of this. So let us take another example. Again, this is a must to know. You have this in your syllabus, counting the number of zeros and knowing the possible number of zeros. So it's part of your syllabus. So here it's very clear. You have 1, 2, 3 zeros for the green polynomial, while the red polynomial is producing a graph which is crossing the x-axis at only one place. But yes, both are your cubic polynomial, x cube, x cube. Both are cubic, but it is giving different number of zeros. So one case it gave us 3, another case it's giving just 1. Okay, so I have 2 more examples. So just have a look. It seems there is an error. Why is there an error? Oh yeah, this should be. That oh, this 2 is. So here you have red line passing through the x-axis at 1, 2 and 3 different places, while the green is just passing through the x-axis at only one place. It looks like, you know, it might be passing a lot of space, but if you zoom in, you'll get to know. And even the zooming in is a bit tricky, right? So you can see it's just passing through only one space. Yeah, and that too it's 0, right? So the green is just passing through only 1 point, while the red is passing 3 points, right? So here too we saw an example for 3 and 1. Okay, so last example, and this too is with an error because I've given a different name for the variables. I've here I typed just x. So same thing again and again. Yeah, let me rearrange. Okay, so we have here a good example wherein you have 1 and 2 zeros for a cubic polynomial and only 1 0 for another cubic polynomial. So we had 2 and 1. So even that is possible, right? So quite simple, quite straightforward. Okay, when it comes to graph, it's very simple. Looking at it and coming to a conclusion, the number of zeros. So yes, even that is part of your syllabus. So you get questions like this. Look at the graph and tell the number of zeros. So from now onwards, you need to pause the videos. So till now, it's been all the introduction. Now onwards is your exercise and everything will come. So now we are going into your core syllabus, Q&A sections and all of those. Right? So please pause the video and figure out the number of zeros in each of this graph. So the first graph, the number of zeros in the first graph is 1. Clearly a cubic polynomial, it is having 2 bends, right? So the number, looking at the number of bends, you can tell if it's cubic or quadratic or linear or anything. So just count the number of bends, 1 and 2. So it's bending 2 times, right? Then the degree will be equal to 3. So it's like the number of bend plus 1. But yeah, the number of zeros are, the number of zeros is 1 in this case. Here the number of zeros are 2. And it's a quadratic polynomial. There is only one bending. The number of zeros here is 1, 2, 3. 3. The number of zeros is here 1. Remember, it is only the x-axis that counts, not the y-axis. The number of zeros here is 1. It's supposed to be that it just touches. I know, I mean, few of you would have been confused that is it touching or not. It's my mistake. I'm not drawn it that well. But yes, it just, I'm trying to show that just touching and going scenario. Here the number of zeros is 1, 2, 3 and 4. Right? It's as simple as that. Okay, so people who are curious, the degree would be 1, 2, 3. So the degree here is 4. Again, it's people who want to know more. So graphical presentation and graphical reading is must for your future maths or anything that is related to polynomials. So pretty much all the field. So graph reading is must. This is the future of how the business or business analysis or any kind of analysis runs. So if you have seen during COVID time, right? I mean, for some of us it's still COVID time, but hopefully in the future it is post COVID time. So point is, graphical representation was used everywhere: media, newspaper, all kind of TV, matlab TV media or newspaper or online chart. Google is one kid who produced a graph, and he was pretty famous. He produced a graph for all the countries and regions and stuff like that. So yeah, graphical presentation is something that you need to learn. So this is a good introduction. I hope you guys learned a lot and enjoyed it as well.